Hello, sleepy friends, and welcome to the Sleep Labs. It's so lovely to have you here. Tonight, we're learning about 100 of the most sleepy facts about black holes. I hope you're safe, comfortable, and super sleepy for the soothing journey ahead. Before we begin, where in the world are you listening from tonight? Let us know in the comments before we disappear into our minds. It's always amazing to see how far these facts travel. If you like drifting off to science, please leave a like and subscribe. It helps this sleepy little channel dream on. And to all of you already part of our Dreamers Circle with your lab coats on, thank you. Your support means more than you know. And so, it's time, let's begin. Take a deep breath, let your body grow heavy, and close your eyes. Fact 1. A black hole is a region in space where gravity is so incredibly strong that nothing, not even light, can escape its pull. They are born when massive stars reach the end of their lives and collapse under their own immense weight, compressing all their matter into an incredibly dense, infinitesimal point. Though invisible, black holes have a profound influence on the universe, bending space and time around them and quietly shaping the galaxies that surround them. Fact 2. At the heart of every black hole lies the singularity, a place where our understanding of physics collapses along with the star. Surrounding it is the event horizon, the invisible boundary that marks the point of no return. Anything that crosses it disappears from our universe as we know it, swallowed by the immense gravity and lost to the fabric of space-time itself. Fact 3. Black holes come in different sizes. Stellar black holes are born from individual collapsing stars, typically many times the mass of our Sun. Supermassive black holes, millions or even billions of times heavier than the Sun, sit at the center of almost every galaxy, including our own Milky Way. Despite their differences, all black holes share the ability to warp reality, reminding us how strange and awe-inspiring the cosmos can be. Fact 4. As matter spirals into a black hole, it forms a glowing accretion disk heated to extraordinary temperatures. In some cases, twin jets of energy shoot out from the poles, traveling millions of light years into space. Black holes are both destructive and creative, breaking down matter but also illuminating and shaping their cosmic neighborhoods. Fact 5. Time itself behaves oddly near a black hole. For a distant observer, someone falling toward the event horizon appears to slow and freeze in place, while the traveler experiences time, normally until gravity stretches it beyond recognition. In this warped realm, seconds can feel like eternity, and the usual rules of cause and effect bend and twist like a dream. Fact 6. When black holes collide, they send ripples across the fabric of space-time called gravitational waves. These waves, first detected in 2015, carry echoes of cosmic events from billions of years ago, telling us stories of collisions that reshaped galaxies. Even in silence, black holes leave fingerprints that reach across the universe. Fact 7. We often discover black holes not by seeing them directly, but by observing their effects on surrounding matter. Nearby stars wobble, gas is heated to millions of degrees, and X-rays flare as material is pulled inward. Black holes teach us that sometimes the absence of something can be as revealing as its presence, whispering secrets across the void. Fact 8. In 2019, humanity captured the first ever image of a black hole, a glowing ring surrounding a dark shadow lying 55 million light-years away. This extraordinary image shows the invisible made visible, a glimpse into a cosmic phenomenon that until recently existed only in theory, proving the power of patience, curiosity, and imagination. Fact 9. Black holes captivate both scientists and dreamers alike. In science fiction, they become portals to other dimensions, doors through time, or engines of interstellar travel. While we cannot safely enter one, the mysteries they present stretch our minds, challenging us to imagine what lies beyond the boundaries of our familiar universe. Fact 10. Even the largest black holes may not last forever. Through a process called Hawking radiation, they gradually lose mass and energy over unimaginable timescales, eventually evaporating. Yet, in their long lives, black holes shape galaxies, influence cosmic evolution, and inspire us to look deeper into the universe, into the quiet, hidden corners where nature bends reality itself. Fact 11. Some black holes spin, twisting space-time around them in a phenomenon called frame. This rotation can cause the surrounding accretion disk to spiral faster and glow brighter, while warping light itself into arcs and swirls. A spinning black hole is like a cosmic whirlpool, pulling everything around it into a slow, elegant dance of gravity. Fact 12. Intermediate black holes exist too, bridging the gap between stellar and supermassive ones. Though harder to detect, these cosmic enigmas may form when clusters of stars collide and collapse, offering clues to how the largest black holes at the centers of galaxies might have grown over billions of years. Fact 13. Black holes can distort not only space, but also the path of light. Gravitational lensing bends and magnifies the light of objects behind them, creating rings, arcs, or multiple images. Observing these effects allows astronomers to map hidden black holes, revealing that even darkness can cast a cosmic shadow of beauty and complexity. Fact 14. As matter plunges toward a black hole, it is stretched and squeezed in a process whimsically known as spaghetti. Gravity's pull grows so extreme that objects are elongated into thin, thread-like shapes before vanishing into the singularity. It is a vivid reminder of the surreal and unforgiving nature of these cosmic giants. Fact 15. Black holes are never lonely. They often reside within galaxies teeming with stars, gas, and dust, influencing star formation and galactic evolution. Their gravity can shepherd stars into tight orbits, stir up cosmic clouds, and even trigger waves of new star births. Architects shaping the universe from the shadows. Fact 16. Even light can be trapped temporarily around a black hole in a place called the photon sphere. Here, photons, particles of light, circle endlessly until nudged inward or outward. It is a hauntingly beautiful region, where the speed of light itself bends, twists, and dances around the invisible heart of darkness. Fact 17. The idea of black holes stretches back over a century, first emerging from Einstein's equations of general relativity. While initially theoretical, countless observations since then, from X-ray bursts to gravitational waves, have confirmed their existence, showing that the universe holds mysteries stranger and more powerful than even our boldest imaginations. Fact 18. Black holes are sometimes found in pairs, orbiting one another in a cosmic duet. Over time, they spiral closer, merging in cataclysmic events that ripple through space-time. These collisions release energy on a scale beyond comprehension, reminding us that even in destruction, the universe leaves behind echoes of beauty. Fact 19. Despite their fearsome reputation, black holes are not cosmic vacuum cleaners. They do not roam the universe, swallowing everything in sight. Matter must come very close to feel their grip. Most stars and planets in the universe continue their quiet orbits without ever encountering one, living peacefully beside these sleeping giants. Fact 20. Black holes are the ultimate teachers of patience and perspective. Observing their distant effects, imagining their invisible interiors, and contemplating their strange influence on time and space reminds us how small, fleeting, and wondrous our lives are. They are both terrifying and beautiful as silent, endless meditation on the cosmos. Fact 21. The boundary of a black hole, known as the event horizon, is one of the strangest and most fascinating places in the universe. It is the point of no return, where gravity becomes so intense that nothing, not light, not particles, not even information can escape. From the perspective of a distant observer, anything falling toward it appears to slow down and stretch, frozen in time, as if the universe itself has paused to watch. Yet, for the object falling inward, time flows normally, and it crosses into the unknown with no way to send a message back. This strange duality between what is seen and what is experienced is one of the many paradoxes that make black holes so mesmerizing. Fact 22. Supermassive black holes, hidden in the hearts of galaxies, can contain millions or even billions of times the mass of our Sun. Yet they are astonishingly compact. Imagine compressing an entire galaxy's worth of stars into a region smaller than our solar system. These giants act as cosmic anchors, holding together the stars and gas in their galaxies. Yet they remain mostly invisible, silent, and inscrutable, their presence betrayed only by the motions of stars around them or the occasional eruption of energy as they consume matter. Fact 23. When two black holes collide, the event is nothing short of cosmic fireworks. Though invisible to the eye, their union sends ripples through the fabric of space-time known as gravitational waves. These waves propagate at the speed of light, stretching and squeezing the universe ever so slightly as they pass. Detectors like LIGO and Virgo on Earth can sense these minuscule distortions, allowing humans to hear events that occurred billions of years ago, long before life even existed on Earth. These whispers from the cosmos transform our understanding of black holes from theory into observable, tangible phenomena. Fact 24. Not all black holes are quiet. Some generate enormous, powerful jets of matter that are expelled at near light speed, sometimes extending thousands of light years into space. These relativistic jets carve tunnels through surrounding gas and can influence star formation and galaxy evolution across enormous distances. Though the black hole itself is invisible, its influence becomes vividly apparent, a paradoxical reminder that even the darkest objects can leave brilliant marks on the universe around them. Fact 25. Black holes grow by consuming matter, but they are surprisingly selective. Gas and dust spiral inwards, forming an accretion disk that heats up to incredible temperatures, sometimes emitting X-rays that we can detect from millions of light-years away. Not everything falls in. Much of this matter is ejected in powerful winds, shaping the surrounding galaxy. In this sense, black holes are both destroyers and sculptors, devouring what they can but also indirectly creating structure and order in their environments. Fact 26. Some black holes wander alone through space, untethered to any galaxy. These rogue black holes drift silently through the vast darkness, invisible to most of our instruments. Astronomers can only detect them through subtle gravitational effects on nearby stars or gas clouds. These lonely travelers remind us that the universe is full of unseen forces, silently moving through the cosmos, shaping the galaxies we can see while remaining entirely hidden from view. Fact 27. While black holes are most often associated with destruction, they can indirectly foster creation. By influencing surrounding gas clouds, a supermassive black hole can compress material and trigger star formation, giving birth to new generations of stars. It is a cosmic paradox, a singularity of destruction that simultaneously nurtures creation, weaving endings and beginnings together in a cycle that spans billions of years and light-years of space. Fact 28. Time behaves in strange and fascinating ways near a black hole. According to Einstein's theory of general relativity, an observer far away will see clocks near a black hole tick slower, a phenomenon known as gravitational time dilation. Meanwhile, someone falling into the black hole would experience time normally, unaware of the slow march from the outside. Near a black hole, past, present, and future intertwine, bending reality itself and challenging our deepest intuitions about how the universe works. Fact 29. Some of the largest black holes formed surprisingly early in the universe's history. Less than 1 billion years after the Big Bang, how matter collapsed and accumulated so quickly to form these cosmic giants remains one of the greatest mysteries of astrophysics. These early supermassive black holes remind us that the universe is capable of extraordinary growth and complexity, often faster and stranger than our current theories can fully explain. Fact 30. Even though black holes themselves are invisible, they leave unmistakable marks on the universe. We can observe them through the radiation emitted by infalling matter, the gravitational waves of merging black holes, or the dramatic motion of nearby stars. The Event Horizon Telescope gave us the first image of a black hole's shadow, revealing the unseen. Black holes teach us that sometimes the most profound presence is felt, not seen ripples in the cosmos that reveal the extraordinary power hidden in darkness. Fact 31. Some black holes spin at incredible speeds, twisting the very fabric of space-time around them in a phenomenon called frame dragging. Near these rapidly rotating black holes, space itself swirls like water around a drain. This rotational energy can power the colossal jets we see shooting into space, and it warps the paths of light and matter in ways that challenge our understanding of physics. Spinning black holes remind us that even in the stillness of darkness, motion and energy can reign supreme. Fact 32. Black holes can sing in their own way. When matter falls into them, or when they merge, they create vibrations in space-time that scientists detect as gravitational waves. Each collision produces a unique pattern, like a cosmic symphony echoing across billions of light years. By studying these signals, we can learn about the size, spin, and even the environment of black holes, giving us a glimpse into events that occurred long before humans existed. Fact 33. Intermediate black holes. A mysterious category between stellar and supermassive black holes are some of the most elusive objects in the universe. They are thought to form from the merging of smaller black holes or from the collapse of massive stars in dense clusters. Detecting them is extremely difficult, yet their existence could explain how supermassive black holes grew so rapidly in the early universe. They are the missing links in the cosmic chain of black hole. Evolution. Fact 34. The idea of black holes was once purely theoretical. In the early 20th century, they were considered mathematical curiosities with no real counterparts in the universe. It wasn't until observations of stellar motion and X-ray emissions in the mid-1900s that astronomers began to realize these invisible monsters were real. Today, black holes are central to our understanding of astrophysics, showing how theory and observation can come together to illuminate the unseen. Fact 35. Black holes can distort the light of objects behind them through a process called gravitational lensing. This cosmic magnifying glass bends and magnifies distant galaxies, allowing astronomers to study regions of the universe that would otherwise be invisible. It's a reminder that even in darkness, black holes can reveal the universe in extraordinary ways, turning their immense gravity into a tool for discovery. Fact 36. Stellar black holes, formed from the collapse of massive stars, are more common than their supermassive counterparts, but far less conspicuous. Many wander silently in our galaxy, invisible to all but the most precise instruments. Their formation is a violent and chaotic process, yet they often leave behind remnants of cosmic beauty, like pulsars and nebulae, demonstrating that creation and destruction often walk hand in hand. Fact 37. Black holes challenge the very nature of information. According to quantum physics, information cannot be destroyed, but anything falling into a black hole seems to vanish forever. This information paradox has puzzled scientists for decades, inspiring theories like Hawking radiation and the idea that black holes may slowly leak information back into the universe. It's a cosmic puzzle that tests the boundaries of our understanding of reality itself. Fact 38. Matter spiraling into a black hole forms an accretion disk heated to millions of degrees. This intense heat produces some of the brightest light in the universe, often outshining entire galaxies. Despite the darkness of the black hole itself, the surroundings can be incredibly luminous, a paradox that captures the duality of these cosmic objects' destruction at the center, brilliance at the edge. Fact 39. Black holes influence the shape and behavior of their host galaxies. Supermassive black holes at galactic centers can regulate star formation, stir up gas, and even drive galactic winds. They act as both anchors and agitators, shaping the evolution of galaxies over billions of years. Though unseen, their gravitational influence is undeniable, silently orchestrating the motions of stars and gas across vast cosmic distances. Fact 40. Even time itself bends around a black hole. Close to the event horizon, the passage of time slows dramatically relative to distant observers. This phenomenon means that while a black hole devours matter, the universe outside continues its course at a normal pace. It's a poetic reminder that black holes are not just cosmic vacuum cleaners, they are profound distortions of reality, where the universe plays by rules that seem almost magical. Fact 41. At the very heart of a black hole lies the singularity, a point where matter is compressed into an infinitely small space and gravity grows infinitely strong. Here, the known laws of physics, our understanding of time, space, and matter break down entirely. Space itself is warped beyond recognition. Time slows to a crawl, and conventional concepts of reality cease to exist. Scientists can only imagine what happens there. But this unknowable heart of a black hole represents one of the most profound mysteries of the universe, challenging physicists to unite quantum mechanics and general relativity into a single theory that can describe the impossible. Fact 42. Black holes are not just cosmic vacuum cleaners, they can form in pairs or even clusters. When two black holes orbit one another, their immense gravitational pull sends waves rippling through the fabric of space-time. Over millions or billions of years, these twin black holes spiral closer together in an intricate cosmic dance, eventually colliding in a spectacular merger. This collision releases an enormous burst of energy in the form of gravitational waves, tiny tremors in the universe that we can detect here on Earth. These waves carry with them secrets of events that occurred billions of years ago, opening a new way of listening to the cosmos. Beyond the reach of light or radio signals, fact 43, supermassive black holes are the titans of the universe. Millions, sometimes billions, of times more massive than our sun. They sit quietly at the centers of galaxies, including our own Milky Way. Despite their massive presence, they often remain invisible, detectable only by the way stars and gas move around them or by the intense radiation emitted from matter spiraling into their accretion disks. These colossal objects don't just sit there, they shape the very formation and evolution of galaxies, acting as invisible architects of the universe. Their gravitational influence regulates star formation, scatters gas, and even controls the dynamics of the galaxy itself, silently governing the cosmos from the shadows. Fact 44. Even the mightiest black holes are not eternal. According to Stephen Hawking's groundbreaking theory, black holes can slowly evaporate over unimaginable timescales through a process called Hawking radiation. Quantum effects near the event horizon allow them to emit tiny amounts of energy, a phenomenon so faint that it is undetectable in stellar mass black holes today. But over trillions of years, this subtle leakage could shrink a black hole until it vanishes entirely. A poetic twist of fate, the most powerful objects in the universe gradually slipping away into nothingness, reminding us that even cosmic giants are subject to the quiet persistence of time. Fact 45. Black holes are gluttons of the cosmos. They feed on stars, gas clouds, and even other black holes, devouring everything in their path with relentless efficiency. As matter falls toward a black hole, it doesn't disappear, silently heats up, spirals faster, and emits dazzling bursts of X-rays and other radiation before crossing the event horizon. Some of these feeding frenzies produce quasars, among the brightest objects in the universe, capable of outshining entire galaxies. Observing these events allows scientists to study the most extreme environments in existence, where gravity, energy, and motion reach levels that cannot be replicated anywhere else. Fact 46. The gravity near a black hole is so extreme that it can stretch objects into impossibly thin shapes in a process known as spaghettification. A star venturing too close would be torn apart, stretched along the direction of gravitational pull while compressed from the sides. Even light and information are trapped once past the event horizon, giving the black hole its reputation as an ultimate cosmic prison. These tidal forces illustrate the terrifying scale of power these objects possess, making it clear that space is a far stranger and more violent place than we experience on Earth. Fact 47. Black holes can also be incredibly creative. They sometimes eject powerful jets of particles that shoot out at nearly the speed of light. These relativistic jets emerge from the magnetic fields in the swirling accretion disks and can extend for thousands of light years, impacting surrounding gas and even influencing star formation in nearby regions. While a black hole consumes matter mercilessly, these jets show that it can also redistribute energy across the galaxy, acting as both a destroyer and a catalyst for creation in the cosmic ecosystem. Fact 48. Some black holes wander the universe alone, silent and invisible. Known as rogue black holes, they drift through space without nearby stars to reveal their presence. Their existence is inferred only from subtle gravitational effects on surrounding matter, or the occasional disruption of a distant star. Imagine a colossal, unseen predator moving silently across the galaxy, shaping the cosmos in subtle but profound ways, leaving behind only hints of its passage. Fact 49. Black holes bend the very rules of reality. Near the event horizon, time slows dramatically, space curves intensely, and light itself can be trapped or stretched into rings. If you could hover near the edge, you'd witness the universe outside accelerating in forward, a paradoxical experience where cause and effect seem to twist and warp. These extreme conditions make black holes natural laboratories for testing the limits of physics, giving scientists rare insights into phenomena that cannot be recreated on Earth, and offering glimpses into the true nature of the universe. Fact 50. Despite being mysterious and potentially destructive, black holes inspire a profound sense of awe. They are both cosmic destroyers and architects, invisible shapers of galaxies and time itself. Each one reminds us of the vastness and strangeness of the universe, stretching our imagination and our understanding of physics. They challenge our assumptions, invite curiosity, and serve as gateways to questions about reality itself, from the nature of time and space to the ultimate fate of matter and energy in the cosmos. Fact 51. Deep in the cosmic darkness, black holes can sing not in sound as we know it, but in gravitational waves, ripples in the fabric of space-time itself. When matter falls inward, or when two black holes merge, they send out vibrations that travel across the universe like low, trembling notes. Scientists have detected these cosmic echoes using instruments like LIGO and Virgo, faint whispers from collisions, billions of light years away. Each one carries a story of unimaginable violence and beauty, a record of the universe reshaping itself in silence. In a sense, the universe hums softly, and black holes are its deepest bass tones. Fact 52. The area surrounding a black hole, where light bends, shimmers, and swirls, is called the photon sphere. Here, gravity is so intense that light can orbit the black hole in circles. If you could hover safely nearby, you would see the universe wrapped around you, stars and galaxies duplicated and distorted, reflections of light looping endlessly before vanishing into the abyss. It would be a place of impossible beauty and chaos, where reality itself bends back upon itself, and sight becomes a form of time travel. Fact 53. Every black hole has a boundary known as the event horizon, the ultimate point of no return. Once something crosses it, not even light can escape. To an outside observer, anything falling toward this boundary would appear to slow down, frozen in time as it stretches and fades, never quite disappearing. Yet, from the falling object's perspective, the crossing happens instantly. This strange contradiction to realities unfolding simultaneously shows how deeply black holes warp our perception of time and existence. Fact 54. The first image of a black hole was captured in 2019 by the Event Horizon Telescope, a network of radio telescopes spread across Earth. It showed a glowing ring of light around a dark shadow, the silhouette of a supermassive black hole in the galaxy M87. That faint, blurry image represented more than a century of theory and imagination made real. For the first time, humanity saw the edge of the unknowable, a photograph of space itself bending under the weight of gravity. Fact 55. Inside the event horizon, all paths lead to the singularity. No matter which direction you move, down becomes toward the center, a one-way journey into infinite density. Space and time trade roles. Movement through space becomes movement through time itself. The singularity isn't just a point in space, it's a destination where every possible future converges. Scientists suspect that inside this heart of darkness, the laws of physics as we know them are rewritten, replaced by something we have yet to understand. Fact 56. Black holes can spin. When they rotate, they drag space-time itself around them in a phenomenon called med dragging. Anything near a spinning black hole, gas, dust, even light, is caught in this cosmic whirlpool, forced to move in the same direction as the rotation. The faster the spin, the smaller the event horizon becomes, and the more energy the black hole can store. Some physicists believe that one day, if technology allows, this rotational energy could be tapped, the most extreme form of cosmic power imaginable. Fact 57. Black holes may hold the keys to the future of the universe. When galaxies collide, their central black holes eventually merge to reshaping entire cosmic structures. Over billions of years, as stars fade and galaxies grow dark, black holes will remain, consuming the remnants of the cosmos. In the far future, when everything else has gone cold and silent, only black holes will still exist, the last keepers of matter, light, and memory, slowly evaporating into the quiet. Fact 58. Scientists once thought black holes could only form from massive stars, but new evidence suggests there may be smaller ones. Primordial black holes, created moments after the Big Bang. These ancient remnants could be scattered throughout the universe, relics from the dawn of time itself. If they exist, they may help explain some of the mysteries of dark matter, the invisible substance that holds galaxies together. In a way, black holes might not only mark the end of life, but its very beginning. Fact 59. The gravity near a black hole distorts not just space, but light and color. As light escapes its grasp, it stretches into longer wavelengths, shifting toward the red end of the spectrum, a process called gravitational redshift. To an observer, this makes the area around a black hole glow faintly, colors deepening into fiery oranges and crimson hues. It's as if the universe itself blushes at the edge of oblivion, turning radiant before fading into shadow. Fact 60. For all their mystery and menace, black holes are not symbols of destruction, but of transformation. They turn matter into energy, shape galaxies, and forge the universe's large-scale structure. They remind us that endings and beginnings are often the same thing, that even in the deepest darkness, there is movement, change, and creation. To gaze into the idea of a black hole is to look into the heart of reality itself, the place where everything known dissolves, and everything possible begins. Fact 61. The immense gravitational pull of a black hole doesn't just draw in matter, it draws in time itself. Near the event horizon, time slows dramatically. A single minute for someone close to a black hole could stretch into years, centuries, or even millennia for those far away. This isn't science fiction, it's the true, measurable effect of relativity. In theory, if you could orbit safely near a black hole and then return home, you'd find that ages had passed on Earth, while only a few moments had passed for you. A black hole, in this way, is not just a force, it's a time machine built by gravity. Fact 62. Every black hole is surrounded by an invisible boundary where the universe itself begins to fold. Beyond this limit, no signals, no messages, no light can ever escape. And yet, right at that border, physics dances in chaos. Particles flicker into existence and vanish again. Light bends into shimmering loops, and the distinction between inside and outside begins to blur. To stand near this edge, even in imagination, is to stand at the threshold of the impossible, where the known universe gives way to something else entirely. Fact 63. When black holes form from collapsing stars, they sometimes send out a final cry, a burst of gamma rays so powerful it can outshine all the stars in a galaxy combined. These gamma ray bursts, lasting only seconds or minutes, are among the most energetic events in the cosmos. They are thought to mark the moment when a massive star's core collapses under its own gravity, tearing space and time before becoming infinitely small. In those fleeting flashes of light, the universe reveals its most dramatic moments of death and rebirth. Fact 64. At the center of our Milky Way lies a supermassive black hole called Sagittarius A*. It sits quietly 26,000 light-years from Earth, weighing about 4 million times more than the Sun, though we cannot see it directly. We can watch the stars near it orbiting at incredible speeds, some completing a full revolution in just a few years. Their dizzying motion betrays the presence of something enormous, invisible, and inescapable. In a sense, our entire galaxy, including every star, every planet, and every one of us, revolves around this hidden heart. Fact 65. When matter spirals into a black hole, it forms a glowing disk of gas and dust called an accretion disk. Temperatures there can reach millions of degrees, and friction between particles produces brilliant X-rays that we can detect from Earth. To astronomers, these disks act like cosmic beacons, allowing them to find black holes even when the objects themselves remain unseen. The light we see from these accretion disks has traveled across vast oceans of space, a ghostly glow from the very edge of time and gravity. Fact 66. It's easy to imagine black holes as perfect voids, but in truth, they are among the most active and dynamic regions in the universe. The space around them churns with magnetic storms, twisting fields, and shock waves of plasma. Particles race around at near light speed, creating bursts of radiation that flicker like cosmic lightning. What appears to us as silence and darkness is up close. A storm of unimaginable power, the universe's most violent ballet, performed in near total secrecy. Fact 67. Black holes play an essential role in the life cycle of galaxies. Their gravitational influence regulates how stars form, controls how gas moves, and can even determine the shape of the galaxy itself. When they feed too quickly, they can blow away the gas that might otherwise have formed new stars. When they sleep, galaxies grow calm and still. In this way, black holes are not destroyers but conductors, shaping the rhythm of cosmic creation with a balance of hunger and restraint. Fact 68. The largest known black hole resides in the galaxy Holmberg 15A and has a mass estimated at around 40 billion suns. Its event horizon, the region from which nothing can escape, is so vast that it could easily engulf our entire solar system. To stand near it would be to see nothing but darkness in every direction, the sky erased by gravity itself. It's a reminder that the scale of the universe exceeds not just our senses, but our imagination, vast, patient, and utterly beyond measure. Fact 69. Despite their power, black holes may one day fade into nothing, over unimaginable timescales far beyond the life of any star, planet, or galaxy. Even the largest will slowly evaporate through Hawking radiation. As they shrink, their temperature will rise, and they will glow faintly, like embers cooling in the dark. When the last black hole finally disappears, the universe will enter a new era, cold, silent, and empty, where only the faintest quantum whispers remain. Fact 70. Black holes show us that the universe is far stranger and far more beautiful than we ever dared believe. They teach us that gravity is not just a force but a story, a curve written into the very shape of reality. They remind us that destruction and creation are often the same process, seen from different sides, and that, even in the darkest places, there is still movement, energy, and the quiet pulse of existence. To think of black holes is to stand in awe at the edge of understanding, to feel both small and infinite at once. Fact 71. Not all black holes are born the same. Some are formed from dying stars collapsing under their own gravity when their fuel runs out. Others, the supermassive ones, seem to have existed since the dawn of time itself, forming directly from dense clouds of primordial gas or merging smaller black holes into giants. In the universe's earliest moments, these invisible seeds may have helped galaxies take shape, pulling together stars, dust, and gas to form the spiraling islands of light we see across the night sky. Fact 72. A black hole's gravity does more than bend light. It warps the shape of the space around it. Imagine stretching a sheet of rubber and placing a heavy sphere in the center. The fabric dips, curves, and folds around the weight. Now imagine that sphere as infinitely heavy, pressing so deep that it tears a hole straight through the sheet. That's what a black hole does to space-time, a bottomless indentation in the universe's fabric, where the straightest line becomes a curve, and the path forward becomes down. Fact 73. The jets that erupt from black holes are among the most powerful structures in the universe. Some stretch across hundreds of thousands of light years, blasting through space like cosmic serene. The energy released by these jets can influence entire galaxies, heating up clouds of gas, altering star formation, and even reshaping the galactic environment. Though born from destruction, from matter being torn apart, these jets act as engines of creation, recycling the universe's energy outward again into space. Fact 74. The first black holes imagined by scientists weren't called black holes at all. In the 18th century, English geologist John Michell and French mathematician Pierre-Simon Laplace described the idea of dark stars, objects so massive that light could not escape their gravity. Centuries later, Einstein's equations made those ideas real, predicting the curvature of space-time that would lead to these cosmic abysses. Yet even Einstein himself doubted their existence, calling them too strange to be real. Now we know they are everywhere, silent, invisible proof of how imagination sometimes precedes discovery. Fact 75. When two black holes merge, they create a moment of pure cosmic violence. The energy released in that collision can exceed the combined light of every star in the visible universe, yet it comes not as light, but as ripples in space-time. These gravitational waves roll across the cosmos, distorting the fabric of reality by less than the width of an atom. And yet, we can detect them. For a brief instant, humanity can hear the universe breathe, a faint, passing tremor from billions of light years away, whispering, "Something extraordinary has happened." Fact 76. If you could hover safely near a black hole, the light from distant stars would wrap around you, looping endlessly. You would see the back of your own head illuminated by light that has circled the hole completely. The stars behind it would distort, stretched into halos and rings, turning the night sky into a kaleidoscope of warped reflections. It would be a vision both beautiful and terrifying, a reminder that perspective in the universe is never absolute. Fact 77. For years, scientists believed black holes could erase information that once matter fell in. Every trace of it was lost forever. But this idea troubled physicists because it violated a fundamental rule of quantum mechanics. Information cannot be destroyed. The information paradox became one of the greatest puzzles in physics. New theories now suggest that the information may still exist, encoded in the faint radiation emitted by black holes or woven into the fabric of space-time itself. In this way, black holes may not destroy history. They may simply rewrite it. Fact 78. Some theories suggest that a black hole might not be an end at all, but a doorway, a bridge to another region of space-time, or even another universe. These hypothetical pathways, called wormholes, are purely theoretical for now, but the equations allow them. If they exist, they could connect distant corners of reality, making black holes not cosmic traps, but cosmic tunnels. It's a poetic idea that the darkest places in the universe might also be gateways to the light beyond. Fact 79. The heat of a black hole increases as it shrinks. That means small black holes burn hotter than large ones. So hot, in fact, that a microscopic black hole would explode almost instantly in a burst of radiation. Some physicists believe that if primordial black holes were created during the Big Bang, the smallest ones may have already evaporated in flashes of light. If so, the universe might still carry the faint fingerprints of their final moments, a ghostly glow from the first seconds of time. Fact 80. The study of black holes is, in many ways, a study of ourselves, of our need to understand the unknown, to face the darkness, and to ask questions that might never have answers. They stand as symbols of both our curiosity and our humility. Every new discovery about them reshapes our view of the cosmos, reminding us that reality is far deeper and stranger than we can ever truly grasp. To contemplate a black hole is to feel the edges of human understanding and to dream beyond them. Fact 81. Black holes are not just destroyers, they are the quiet architects of galaxies. Their gravity sculpts the dance of stars, shaping entire spiral arms as if sketching them with invisible hands. In the Milky Way, our own black hole, Sagittarius A*, sits in the galactic center like a heartbeat, massive, patient, and ancient beyond measure. Every star in the night sky, every shimmer of light we see, orbits under its influence. It doesn't devour indiscriminately. It balances, it anchors. Without its pull, our galaxy might unravel into cosmic mist. The same gravity that can tear apart a star is also the force that keeps the heavens together. It's a paradox of creation and destruction. The same hand that crushes also holds the universe in place. Fact 82. At the edge of every black hole lies the event horizon, the final threshold, where time and space bend beyond recognition. To cross it is to leave the known universe forever. No signal, no light, no memory escapes its grasp. Yet, from a distance, the fall never truly happens. To an outside observer, you would seem to slow, stretching thinner and redder until you simply fade, frozen on the edge of infinity. It's as if time itself hesitates there, unwilling to cross the boundary. Scientists call it a one-way door, but it's more like a pause in reality, a place where the universe stops to take a breath. No one knows what waits inside, but that mystery might be the most beautiful part. A reminder that even in a universe of laws, there are still places where wonder lives untamed. Fact 83. Inside the event horizon, all logic collapses. Space twists upon itself. Matter folds tighter than the mind can conceive. The laws of physics, so steadfast in the visible world, break and scatter like leaves in a storm. The singularity, the heart of a black hole, is thought to be infinitely small, infinitely dense, but perhaps it's not a point at all. Some scientists believe it could be a bridge, a tunnel connecting one universe to another. If that's true, then black holes are not the end, but the beginning cosmic seeds that bloom elsewhere in unseen realms. Perhaps Somewhere out there, entire galaxies spin in a universe born from the death of another. Maybe every ending, even one as dark as this, hides the start of something new. Fact 84. Every black hole begins with a death. When a massive star runs out of fuel, its own weight becomes unbearable. Gravity wins the battle against light, and the star collapses inward with astonishing violence. The explosion that follows a supernova can blaze brighter than a galaxy visible across millions of light years. But what remains after the light fades is silence, a remnant so dense that nothing can escape. It's a strange kind of afterlife, a star that burns so fiercely it becomes invisible. And in that quiet remains the proof that even destruction can leave beauty behind. The remnants of those explosions, heavy elements like gold, platinum, and silver, are scattered into space, eventually forming planets, oceans, and even us. In a way, every breath we take began in the death throes of a star that gave everything to gravity. Fact 85. When a black hole feeds, it performs one of the most extraordinary shows in the cosmos. Gas and dust spiral inward, forming an accretion disk, a glowing halo of light heated to millions of degrees. The material spins faster and faster until magnetic fields twist and launch jets of radiation and plasma into the void, sometimes stretching across thousands of light years. These jets carve paths through interstellar space, shaping galaxies, triggering new stars, and marking the universe with patterns of light and energy. To watch a black hole feed is to witness the universe both devouring and creating destruction turned into art, gravity turned into choreography. What we see as terror might simply be nature's way of rebalancing itself, turning chaos into beauty in the most literal sense. Fact 86. Though they seem eternal, even black holes die. Over unimaginable stretches of time, they lose mass through something called Hawking radiation, a faint whisper of energy that leaks away from their edges. The process is so slow that it defies comprehension. The largest black holes will take trillions upon trillions of years to fade completely. When the last of them finally evaporates, the universe will be silent. No stars, no galaxies, only the gentle hiss of fading energy. It's poetic to think that the universe's loudest phenomena, the roaring birth of black holes, will end in quiet, a soft fading into nothing. Even the darkest things in the cosmos are temporary, dissolving eventually into the same stillness that began it all. Fact 87. Some black holes spin, and when they do, they twist space-time around them like a whirlpool drags the surface of water. This effect, known as frame dragging, means that near the black hole, even time itself begins to swirl. A particle caught near such a monster can orbit at nearly the speed of light, endlessly looping in a dance it can never escape. Around the most extreme of these rotating giants, matter doesn't fall straight in. It flows sideways, caught in an eternal spiral. The universe, it seems, doesn't just pull, it twirls. The idea that gravity itself can twist the fabric of reality reminds us that space is not empty, it's alive, elastic, and full of motion. Fact 88. When two black holes meet, the universe shudders. They circle each other in a death spiral for eons, moving closer, faster, their orbits decaying with every revolution. When they finally collide, they merge in a flash of invisible violence, releasing ripples through space-time itself. These ripples, called gravitational waves, travel across the cosmos, bending reality as they go. In 2015, we heard them for the first time, a faint chirp picked up by instruments on Earth. The sound of two black holes colliding more than 1 billion years ago. It was the universe speaking, whispering proof that Einstein's wildest ideas were true. Every such collision is a reminder that even across unimaginable distances, the cosmos is still in motion. Still breathing, still singing its deep. Slow song. Fact 89. Some black holes might be ancient beyond imagination. Relics from the earliest moments after the Big Bang, these primordial black holes would be smaller than an atom, yet heavier than a mountain, formed when the infant universe was still thick and wild. If they exist, they could be drifting through space all around us, silent and unseen, tiny distortions in the fabric of everything. Some scientists even suspect they could make up part of the mysterious dark matter that fills our universe. If that's true, then black holes aren't just rare cosmic monsters. They're everywhere, woven into the very texture of reality itself. Fact 90. What if everything a black hole swallows isn't truly gone? Some physicists believe that the surface of the event horizon, that thin, glowing boundary, holds a record of everything that's ever fallen inside. Not in physical form, but as pure information etched onto the fabric of space itself. This is called the holographic principle, the idea that the universe might be like a projection, where three-dimensional reality emerges from data written on a two-dimensional surface. If this is true, then black holes aren't graves of matter, but libraries of memory. Every photon, every atom, every secret devoured by gravity still exists somewhere in the code of the cosmos. In that sense, nothing is ever truly lost. The universe remembers everything, always. Fact 91. The space around a black hole is not empty. It's alive with turbulence, magnetism, and heat. Gas swirls and collides, generating light so bright it can outshine the combined glow of billions of stars. Yet, from a distance, we see only darkness, a silhouette outlined by the luminous chaos surrounding it. This is how we've photographed the unseeable, by tracing the light that dares to come close but not cross the edge. In 2019, scientists unveiled the first ever image of a black hole, a glowing ring of fire circling a shadow. It wasn't just a picture. It was proof that even the darkest mysteries can be touched by light if we look carefully enough. Fact 92. Time behaves strangely near a black hole. The deeper you fall into its gravity, the slower your clock ticks compared to someone far away. To an observer watching from safety, a person approaching a black hole would seem to move slower and slower, frozen just above the event horizon. But to the person falling, time would feel normal, only the rest of the universe would appear to race forward. Billions of years flashing by in moments. In this way, a black hole is a time machine of sorts, allowing a glimpse into the far future, but only at the cost of never returning. Fact 93. Not all black holes are enormous. Some are only a few times the mass of our Sun, born from the collapse of single stars. Others, the supermassive ones, can weigh billions of solar masses, anchoring entire galaxies. Between these two extremes might exist the intermediate-massed black holes, rare and elusive, hidden in star clusters or dwarf galaxies. Finding them is like finding the missing link in cosmic evolution, the bridge between stellar death and galactic birth. If we can uncover where they hide, we might finally understand how galaxies and even the universe itself learned to grow. Fact 94. The gravity of a black hole can bend light into circles. When light from distant stars passes near one, it curves around it, looping in perfect orbits before escaping again. This phenomenon, called gravitational lensing, can magnify and distort the view of objects behind it, turning space itself into a natural telescope. Some of the most distant galaxies we've ever seen were revealed this way through the bending power of invisible giants. It's strange to think that something that consumes light can also help us see farther than we ever could without it. Fact 95. The edges of black holes flicker. The accretion disks that orbit them aren't smooth or steady. They ripple, flare, and pulse with unpredictable bursts. These rhythms, some lasting seconds, others minutes, are like the heartbeat of the universe. Astronomers record these flickers like music, translating X-rays into sound to listen to a black hole's activity. What they hear is haunting, deep, echoing hums that rise and fall like breathing. It reminds us that even the most alien phenomena in the cosmos follow patterns, cycles, and songs of their own. Fact 96. Black holes may hold the key to unifying the laws of nature. In their extreme conditions, gravity, time, energy, and quantum mechanics all collide. The very ingredients that physicists have spent a century trying to combine into one theory. Some believe that solving the mystery of black holes will reveal the foundation of reality, itself a single elegant equation that explains everything. Perhaps, one day, when we finally understand what lies within, we'll understand why there's something instead of nothing, and how the universe learned to think and see through us. Fact 97. Though black holes seem distant, their influence reaches everywhere. Without them, galaxies would not form as they do. Stars would not cluster. Life, perhaps, might never have found stability in the spiral arms of the Milky Way. Their invisible pull is part of the cosmic balance, silent, stable, and omnipresent. Even in the vast emptiness between stars, their gravity shapes the paths of light and dust, drawing faint order from chaos. Every night sky we gaze upon is a picture framed by their unseen hands. Fact 98. Some theories suggest that every black hole might give birth to a new universe. In this view, the singularity inside is not a dead end, but a bridge, a cosmic womb where space and time expand outward on the other side. Our own universe could have been born from such a place, the offspring of another reality. If that's true, then creation and destruction are not opposites, but partners, an endless cycle of worlds collapsing and beginning again, each one seeded by the last. Somewhere out there, perhaps, new galaxies are blooming right now inside black holes of other universes, carrying the echoes of our own. Fact 99. Black holes connect to one of the deepest paradoxes in science, the information problem. If everything that falls into a black hole is destroyed, then the laws of quantum mechanics, which say that information can never truly vanish, are broken. If the information somehow escapes, then the laws of relativity are wrong. The universe, it seems, cannot make both true at once. Decades of debate, from Hawking to modern theorists, have circled this paradox like light around an event horizon. The answer, whatever it is, may reshape our understanding of existence itself. Fact 100. Perhaps the greatest mystery of all is how something so dark, so silent, could capture our imagination so completely. Black holes represent everything we fear and everything we seek. The unknown, the infinite, the edge of understanding. They are reminders that curiosity is stronger than fear, and that even in the deepest darkness, we reach for knowledge, for meaning, for light. To contemplate a black hole is to feel both small and infinite, at once a heartbeat in the cosmos, listening to the echo of eternity calling back. And that, sleepy friends, brings us to the end of our journey, drifting through the shadows, the mysteries, and the quiet infinities of black holes. If you're still awake, congratulations. Most people fall asleep long before this moment. And if you did drift off somewhere around fact 47, well, that's perfectly okay too. That's exactly what this little corner of the internet is for. If you enjoyed tonight's gentle wander through the cosmos, a like and a subscribe truly help this sleepy channel float through the void. And to all of you already supporting the Sleep Labs, thank you. You're the gravity that holds this dream together, wherever you are in bed, on a late night walk, resting between thoughts. I hope you feel calm, safe, and a little more connected to the strange wonders of the universe. Until next time, dear dreamer, sleep deeply, rest softly, and may your night be as peaceful as the quiet between the stars. Good night, and see you soon.